This one's going to deal all with inequalities of all sorts. So this one says to write the compound inequality shown by the graph. Okay, hopefully you guys remember that when we did this, inequalities that have an or in them are almost always in opposite directions like this. Worst case scenario, they'll all go off in one direction. So very rarely, if ever, do you see this as an and. So I would say you could cross out the and parts. And let's just look at the or ones. Okay, this one says right here, close dot, and to the left, which would be less than. So it's at -5. So this to me says x is less than or equal to -5. Well, that's C. See what I mean? X is greater than 3. There's no closed dot here, so it's a regular inequality. So the question was it C or D? It's C because it had an equals to symbol for 46. Alright, let's go to number 47. So it says solve and graph the solutions of the compound inequality. We sort of solve a compound inequality the same way you would solve any regular one. You just take it, make sure you do whatever you're doing to the middle part to get x by itself. You want to do that to every part of it. So I'm going to add 2, but I'm going to do that everywhere, like this. So it's going to be 3 less than 3x less than or equal to 12. Then I'm going to divide by 3 everywhere. 1 less than x less than or equal to 4. So I read this as essentially x is between 1 and 4. So the shading should be between 1 and 4, and 1 should be open and 4 should be closed. So where is it between 1 and 4 with 1 is open and 4 is closed? I'm saying that's C. Look at the shading. Open on 1, closed on 4, shading between. Number 48, solve the compound inequality. This one actually has an or in it, so we should expect that the inequality shading should go off in opposite directions. So I'm thinking we could probably eliminate B and C, but let's just make sure. Alright, the first one, I'm going to subtract 4 from this one. That's going to say S is less than, well, let's see, negative 2.5. Or, now I'm going to subtract 3. S is greater than or equal to 4. So I need a regular inequality less than on negative 2.5. Well, here's a closed one that would be less than, so A is no good because this is closed. That's no good. B, there's 2.5, but its shading will be going to the right, which would be greater than, so this is no good also because it's closed and it's going in the wrong direction. This one is open, but it's going to the right. I need it to go to the left. You need that. So C is no good. It's got to be D. Let's go to number 49. It says write the inequality shown by the graph. This ought to be pretty easy, right? We have a closed circle on negative 3 and greater than shading. So M has to be greater than or equal to negative 3. Must be C. Number 50, same kind of thing. Write the inequality shown by the graph. I see a closed circle on 4.5 with shading less than. So M is less than or equal to 4.5. Must be B. Hopefully you get a lot of those. Number 51, it says to join the school swim team, swimmers must be able to swim at least 500 yards without stopping. Let N represent the number of yards a swimmer can swim without stopping. Write an inequality describing which values of M will result in a swimmer making the team. So they have to swim at least 500 yards. So how do we say that? N has to be at least. So it could be okay to be 500, but it must be at least that. So like anything less than 500 would be no good. So we're talking greater than 500. But we also can say that 500 would be okay because it says at least that. So we can say greater than or equal to, which has to be D. Number 52, Denise has $365 in her savings account. She wants to save at least $635. Write and solve an inequality to determine how much more money Denise must save to reach her goal. Let D represent the amount of money in dollars Denise must save to reach her goal. Okay, well, she already has $365, and she's going to add some amount of money to that, and what she wants is at least $635, so that number has to be greater than or equal to $635. So if you were to solve it, so this is our expression, which means it's either going to be A or C. If we solve it minus 365 on both sides, you're going to get D is greater than or equal to 270, which means that she needs at least $270 more to make it work, which tells us the answer is A. Okay, it says 53, Marco's drama class is performing a play. He wants to buy as many tickets as he can afford. If tickets cost $250 each and he has $14.75 to spend, how many tickets can he buy? Okay, well again, like we can say that T is the number of tickets, right? $250 per ticket. Basically what we know is that it can be anything up to $14.75. So it's okay if he spends $14.75, but he has to spend something that or lower. So we write less than or equal to, and we divide. So I think what you're going to find is that that is not quite a whole number. It equals 5.9. So what do you think the right answer is? Would it be B, 5 tickets, or C, 6 tickets? Okay, so he has enough money. Essentially what we're saying is to buy 5.9 tickets. But if you think about it, what that really means is he doesn't have enough money for 6 tickets. So even though 5.9 would round up to 6, he actually doesn't have enough money to buy 6. So he can only buy 5, and he'll just have some change left over. So the answer is B. That's a real common kind of mistake problem, because you normally think that 5.9 rounds up to 6, so the answer would be 6. But you got to be careful when you're looking at an inequality like that. Okay, Mrs. Williams is deciding between 2 field trips for her class. The Science Center charges $135 plus 3 per student. The other one just charges $6 per student. How many students will the Science Center charge less? For how many students will the Science Center charge be less than the Dino Discovery Museum? Okay, well, we got to look at it like this. We would say that 135 plus 3 per student, we'll call X the number of students. And so the first one is 135 plus 3x. That would give us our total. And the other one is just 6 times the number of students is our total. So this is an inequality, but we'll come to why it's an inequality in a second. If we solve this out, we're basically saying take the 6x and put it where t is. So it would be 135 plus 3x equals 6x. If we take the 3x away from both sides, I know I'm solving this like an equation right now. You'll see why in a second. And then I divide by 3 on both sides. X is 45. So we're talking about 45 students. That's the magic number, right? Okay, because I think we know that the place that charges $6 per student, it's going to be more expensive after a certain point. But right now, I mean, think about it. You're paying $135 automatically, but only $3 per student. But you still have to pay $135. So think about it. If you have one student, right, just one student, the first place would be $135 plus $3. That would be $138 to go to the Science Center. But the Dino Discovery Museum would be $6. So obviously the Dino Discovery Museum is cheaper for a while, but sooner or later, because it's charging $6 per student, the other one is charging $3. after a while, the $6 per student place will actually be more expensive than the other one. So how long? Well, as it turns out, if you make them equal to each other, what you find is that 45 is like the magic number. 45 is the number of students where it would be equal at both places. But once you go beyond that, it actually becomes cheaper to go to the Discovery Center, the Science Center, sorry, to go to the Science Center. So what we're saying is then for how many students will the Science Center charge less than the Dino Discovery Museum? Okay, when is the Science Center less? Okay, remember that the Dino Discovery Museum was less in the beginning until we got to 45 students. So when will the Science Center charge less? Once you go beyond 45 students. The way we say more than 45 students, see. That's kind of a tricky problem. That's a tough one, but I like that. It makes you think a lot. Alright, so number 55 gives us a graph. These are great because they test your ability to read a graph and match it up to an inequality. So here's what I see. I see two solid lines here, which tells me that both inequalities have to have an equals to some wonder, because solid lines mean an equal to, whereas dashed mean regular. So because both are solid, I know that I can eliminate the ones that have regular inequalities in their answers. So B and C are definitely out because of that. Okay, so then I look at one of them and I see on this line the shading would be down from it, and on the other one the shading would be up. So I better have shadings that are, I better have a greater than and a less than equal to. And so if I look at A, it is greater than and less than, and D is less than and greater than, so we can't eliminate any from that, but it's always a good chance to try it. Okay, so I look at the y-intercepts then. This line right here, its y-intercept is right here at -2. So what I know is the one with the y-intercept of -2, well, if I look at it right, this one has a y-intercept of +2, and this doesn't have a y-intercept written at all, so it would be 0. This one has a -2, and this one has a -1, so it's got to be A based on that. But I also would look at it and say that the line with the y-intercept of -2 has up shading, so it better be a greater than, and it is. So there's any number of ways you can do this, but my advice is try to piece these problems together by eliminating answers. Right? We would eliminate this one because there is no y-intercept equal to -2 here. Not to mention that the shading had to be greater than on it to begin with. So we didn't even really have to mess with the other line, and we already figured out what the answer was. Okay, number 56 says the graphs of systems with inequalities and give two ordered pairs that are not solutions. I'll give two ordered pairs that are solutions and two that are not. So, wow, okay. So, first off, we ought to make sure we know that we graph the lines correctly. So, again, I look at this and I'm looking for solid and dashed lines, and it looks like we have that across the board here. So, I look at the first one and I say this should be at +2 for a y-intercept, and it should be a dashed line with down shading. So I'm looking at the dashed line and looking for any that are +2. Okay, so here, look at the dashed line, right? Here's the dashed line. Sorry, I gotta bring it up for you to see it. This is the dashed line right here, and it's definitely not at +2, so this one is eliminated. But the other ones all have a dashed line starting with a y-intercept at +2. The slope is supposed to be down 3 and over 1. So that one is okay. So is that one. So is that one. So far we're still good on the graphing. So I just put the y-intercept on there, and then I counted the slopes using rise over run. And so far we're still possible for all three of those. So then I look at the shading. It's supposed to be less than, which would mean down from that line. So the shading should go, here's the line. The shading should go down from it. So that one is still okay. Here's the line. The shading should go down. This shading is going up. This is no good. So we can eliminate C. And D, again, we should have down shading. This one is up from this line. So this is no good also. We can eliminate D. So again, because D had up shading when it's supposed to be a less than for that one, it's incorrect. So the only possible answer is actually A. But let's take a look at this part about the solutions, just in case you have to go farther than this. 0, 0 is a solution. Okay, here's 0, 0. It's in the shading area, double shading area. That means it's a good answer. -4, -5 is down here. Also in the shading area, double shading, which is good. 2, 2 is over here, not in the shading area, so it is not a solution. And 10, 1, which will be way out here somewhere, it also not be in our double shading area. So A has got to be correct for any number of reasons. But as you can see, we eliminate the possible answers by just looking at whether or not these things were graphed correctly. Okay, on to number 57. Same kind of idea, graph the system of linear inequalities. So again, I see all should be solid lines because these are both regular inequalities. So I work on the first one then. I should have one that's at +4 for a y-intercept. So 1, 2, 3, 4. And it should go up to and over 1. And its shading would be upward if I did it like that. See, this one looks good to me so far, but I'm a little bit questionable about A, except that, you know, if both shadings were up, we would be okay. So we're going to leave them there for a minute. Let's look at B. B, we have a mess of shading. It's everywhere. I don't think that's going to be true. But, you know, let's mark our regular line on there. I mean, so really it seems sorta okay, maybe. I think we can definitely eliminate D because look, D has down shading from that line, so D is no good. Right, see, when we put here's the line, it's drawn correctly, y-intercept of 2 and a slope, y-intercept of 4 and a slope of up 2 over 1, but the shading is down, it's supposed to be up, so D goes away. Let's look at the other one though. Let's see if we can work it out. Okay, we're supposed to have a y-intercept at -2 and down 2 over 1, or excuse me, up 2 over 1 for the slope, and the shading should be down. So I mean, C looks like it's the right answer to me because this one had up shading and this one had down shading exactly how it's supposed to. So it seems like it's going to be C. If we look at A, right, here's the thing, the slope is here, the line is drawn correctly, but the shading should be down. So A is no good. And for B, up to 2 and then over 1, and this shading should be down. Okay, well then the question is how do you figure that, right? If this one was shaded up and this one was shaded down, why is this area here even shaded at all? So it's not right. It's got to be C. Okay, let's look at number 58. Back to number lines again. It says to join the school swim team, swimmers must be able, we just did this one. Right, I think they got a repeat here. Well, you guys got lucky, right? They have to swim at least 500 yards. n greater than or equal to 500, right? Remember that one too. Got a repeat in there. Sorry about that, guys. Alright, so let's look at number 59 then. It says, Fly With Us owns a DC-10 airplane that seats 240 people. The company flies this airplane only if there are at least 100 people on the plane. See that inequality right there? At least 100. We had a compound inequality. That means two inequalities, somehow or another, to show the possible number of people on a flight on a DC-10 with Fly Us. Let n represent the possible number of people in the flight. Okay, so what do we know? Well, the max is 240. And the minimum is at least 100. So we can have 100 and we can have 240. That's why when we look at our numbers over here, why you're seeing 100 and 240s. Right? See, this one says anything less than or equal to 240. Remember, we have that rule about it has to be at least 100 though. So for example, 10 would be less than or equal to 240, but 10 doesn't go for this plane. You need at least 100. So D is out. Alright, let's think about it. So we're saying it's 100 and 240. We can be less than 240, but you could also have 240, so it's less than or equal to 240. And you can also have to be at least 100, so it means that n would have to be greater than or equal to 100, or in other words, 100 has to be less than or equal to n. So it looks like our answer is going to be A. Alright, for number 60, it says Sam earned $450 during his winter vacation, and he needs to save $180 for a camping trip over spring break. He can spend the remainder of the money on music. Write an inequality to show how much he can spend on music and then graph the inequality. So essentially what we're saying is that he has $450, but he's going to save $180 for camping. So the remainder of the money. So what I'm thinking is, well, alright, basically we're taking the $450 and we're losing the $180 that he has for camping. So I mean, really we know that number is $270 for music. He wants. So what do we know? He can spend up to $270 on music then, right? So a max 270. So we would say that that number has to be less than or equal to 270. Right, so we should know our answer has to be less than or equal to 270. Here's that answer. So our answer is going to be C. But if you think about it, how do we write that equation? Well, we're basically saying that we have 180 for the camping plus the music money, and he has to be at a maximum of 450. So that's where that inequality comes from. But maybe prior to writing the inequality, if you just think about what's happening there, you come up with the answer anyway. Okay, that's it for this one. I'll slide that over so you can see it. Sorry about that.